Hello guys, welcome to KickJS series, and I did a manual setup of KickJS using the TSX to run everything, and this is the code currently. So I'm going to use the KickJS CLI to start a new project. I'm just going to override whatever we have here. So just from the terminal, Windows terminal here, yeah. So let's just close that, start again. So how do you create a KickJS project? Okay. So if you come to the KickJS documentation, you'll see we have, this is the approach for creating KickJS application, right? So npx npx at forinda KickJS CLI, new my API, okay? So let's use this. I'll just take this here, copy, come to VS Code, pnpm. So I'll use pnpx instead of pnpm, CLI, new. So I want to create a new project. What is the project name? I'll use the current folder. Then it should ask me a series of questions. Okay, so this will override everything that we have in the current folder. So let's wait for it to set up. So it's a directory. This is not empty. We have not modules, packages, and those. So it's asking me to remove all existing files. I'll select yes. So it has cleaned up everything. Which methodology I want to use? REST, Express, Swagger, or let's go with minimal, just minimal to get started. Also pnpm for this, we'll use custom name, maybe just test for now. It will ask us for the schema library we're using. I'm going to use Zod because that's what I use majorly. I'll select Swagger and DevTools to install Y for this. Initialize Git repository, no. So install dependencies, yes. So it will create the project in the background, set up everything for us as we wait for all the packages to be installed. All right. So schema library, initially we are using Zod. It was so much tied to Zod, but we decided to extend it so that it can support wider ecosystem. And currently we're just having a bunch of third party. So we removed a few things here and there, but for now let me just walk you through whatever we have here. Okay, I've seen some issue, so I'll just need to resolve them. So post install scripts that are disabled, so by default pnpm will disable them, so I'll just set them to true, then run pnpm install. Right, so it will rebuild those ones, then you're good to go. So let's take a walk through this project. Okay, so at the root, this is the scaffold that it has generated for us. Another nice thing you'll realize, do we have KickJS? We also have, I think it should come up only when I start this server. Let me try and start this server. if that will work. So we have the server running on port 3000. I'm not sure if KickJS is able to detect, or don't I have? So we have this plugin, KickJS Dev Tools. I'm not sure it's not showing here actively, but okay, that's story for another day. So we have KickJS already running here. So if I go to the browser, try and refresh, you'll get not found. So this is the default page you'll get when you try to access a KickJS application from the browser. Then now we need to start wiring things up. Okay, so let's explore what we have. Okay, so at the root we have vtest. This is now the configuration for testing with vtest, that is vit. We are having vit here, and you can see we have a bunch KickJS vit plugin and env watch plugin, which now detects your environment variable changes and make sure that the environment variables are injected into the application anytime you make a change to your environment variables. So you can see we are passing swc vit KickJS plugin, and we give it the entry point to the application so that it's aware. Then we have the env watch here. We are also having path aliases already set, and these transformations. Okay, so in the ts config we just have basic setup here, and the paths are already set up for you, so you don't need to worry about them. We have the readme, which is more of just basic setup. If you look at it, just a minimal KickJS application with dev scripts, starter scripts, folder structure, and the packages we are having. So you can see we also have some adding new features to the application. Just basic setup here and reference to the KickJS documentations and the reference here, CLI reference. Package JSON, what do we have? The scripts, just normal scripts, dev debug, build, start. We're just using the kick CLI to run them. Tests, type check, type gen, then also have linting. Dependencies here we have KickJS, then we also have the KickJS schema. I'll show you why we have that there. Then we have .env, express, reflect, and we have Zod here. Okay. Also we have Swagger and the dev tools. So these are Swagger is for auto API documentation, then dev tools just for inspecting the application. We also have the CLI and vit, swc, types express, types node. So some of these are just to aid in the bundling of TypeScript. We also have prettier already set up here for us, so we can do the formatting. So inside here we have kick config. So we have our we also import kick define config from KickJS CLI. Pattern is minimal. So this is now what dictates this. These are the variants we are having. So can have either REST, which has Express and Swagger, domain driven, CQRS, and just a minimal setup. Package manager set to PNPM. So this now uses it's the one which now when you're adding something, it will use that to install the extra packages. Inside the modules, you can see we have the directory for the modules setup, repo name, test. So this is generally used for code generation. so you don't need to worry about it. Pluralize also is for code generation. For type gen, we are using the schema validator we are using is the KickJS schema, so that's why I was telling you about the KickJS schema. So I'll change it a bit so that you see how it works. Here we have some commands that you can use, so you can add custom commands here so that KickJS is able to do them for you. So you just define the name, your description, then the steps to do it. The steps can be also an array, as you can see here. So it can just be simple string or an array of actions needs to be done. Yeah, like this one here. So do we really need commands now? Not really. So we can just keep this lean, save. We have a cloud config, so if you're using cloud, we have the cloud file which now has the metadata to this project, pre-trc. This is now for formatting, just ignoring basic things. Git attributes for attribution of the project files, env example, we have this, and starter env. Okay, these are just basic setup files. We also have the .agents and the skills for each and every concept KickJS is having. If you have let me see, if you are developing using the agentic flow, it should be able to generate these skills for you. So the CLI commands with the names and the description here. So yeah, there are just a bunch of things here. You can just explore the .agents folder for the skills. Then you also have the KickJS. Now this way, now type generation goes in place. So the next place here is now to explore the root of our folder. So in the SRC we have let me clear that. We're just importing Bootstrap, and we are also importing config. Above here you can see we are importing reflect. Okay, let me just restart my TS server. Looks like things are not reloaded yet. So we have a Swagger adapter, DevTools adapter, and we have the modules. So around here you'll see we have the Swagger details. We're just passing basic information, which is now dependent on the project itself. So we have DevTools adapter also set up here. This is how you use it. Okay, that's it. So if now we explore the modules section, you'll see we have just one module, hello module. Okay, we have this hello module. For that module, you'll see that we are importing define modules from KickJS, then calling it, then we are mounting another module. So when you mount, you call the module you want to mount. If now we go and explore the hello module, you can see we are using define modules. Then you pass the name, then you have this build section where you can return your routes. Yes, if you need to register dependencies, now you can use this section to register dependencies. So it's commented out for now because we are not using it at the moment. So in the route section, you have your path and you have your controller passed there, right? So now if we go to go back to index at the root here, we can also have middleware. I need to add a middleware here. Middleware, it's middleware not plural, so request log. So I'll just pass this request logger middleware. So here you can pass your express middlewares like express.json. You can just pass them there. So if I send this now, if I check my console, you'll see we are getting API v1 test 404, and this is the request ID. Okay, so that is that. You can see Vit is invalidating these ones to make sure that we serve the fresh context of the files that we are having. So that is basic setup for this application if you're using the CLI. But now going to the modules as we discussed, the hello module. These are now just the things that we are having to run or execute, return these routes. So if now we go and see the controller itself, you'll see we are auto wiring the hello service. Then now we have our index, which gets the index, which will serve the request at index. Then we're using this ctx. Then we pass the kick routes. Then we pass the controller name and the name of that function, which is should match this. Now should give you something which is type safe. For now, we're not using the body, that's why you can't really see the benefits, but in a bit you'll get to see why we pass it like this. So in our service, let's explore what's in our service. If you come to the service, what it's doing is just we have the grid, just pass the name and the health check section. Now with this booted, we can test in the browser. We can go to docs, should be able to serve us the Swagger documentation for this, and you can try out, execute, and you can see we are getting this message, hello hello world from KickJS. All right, so that is the basic setup phase for KickJS. So let me just, instead of having that as default in the controller, I can add at API tags. So let me just have it as control. If I refresh this, now you can see we have hello bound here. So with that in place, let me now walk you through some concepts here that we are having. Let's walk through the configuration bit if you want to now start configuring your application. So let's say you need to get some variables from your env, okay? So from the env, if you check the configuration, at the root of the source, we have the config section where we have the index file. This is the convention, it needs to be like this. So this is now more of how it's supposed to be. All right. So this is based on the current version that I am having, the latest version. So if you are using the old version, what you'd have here, instead of this, you'd have you'd have something like define config. Let me just define env and load env. So in here you'll have the define env, which should have been a function which returns, we'd have a base. So this base would be a Zod base. Okay. So then we import Z from Zod, that remains. Then we need to wrap this, okay? So format document. So it would be base dot extend. So you would extend the new ones that you'd want to. How do you extend these? I'm not sure if that will work. Okay, so this is how you would extend your. This is how you do the setup for your environment loading. Okay, so you'd extend with the new ones you're having. So let's say this app name, then remove this. Log level, I'll go with debug. Okay, so then we can have database URL to be that, the URL. Okay, then here we'll just load env, then we export this. The env should now extend the base, of which base comes with port and node env. So whatever we have added here is just the log level, app name, and database URL. So once these are in place, what you'll need to do, then you extract, for you to be able to use this, let's say you come to your service, right? Come to your service, then I want to access the environment variables in my service, okay? So maybe I want to use it for some API connection or third-party integration. I'll just say at value. Now we'll use the at value decorator now to inject, and you can see we are getting the same, the keys that we are having in the env schema here. So let me say app name, private read-only app name. So I'm just having this exclamation to make sure that tell TypeScript that this will not be null. Okay, so it won't be undefined. So instead of name here, I'll just pass app name. Okay, but this now will be this dot app name. So okay, so let's have that name here, which will be a string. Hello name. So we'll have the name here, then add some formatting there. So currently, if now we go to hello, where was that? So do we have the name? Execute. You can see we are getting some funny errors here. This is now vit default errors shown here. So if you check the logs, you'll see we are having some errors, invalid. So it's validating the environment variables you're supposed to be passing. It's saying database URL was not provided. Now if we go to our env, so let's say Postgres, I don't know, Postgres, oh god, user password at local host, maybe 50, 52, 34, I'm not sure. Okay, let's go with that. Should be able to reload env automatically. So env has been changed, but if we try to execute this, now you can see we are getting hello 3000. Okay, hello world 3000. So if now we come and check the service, so wait, what did we pass here? App name, where's the 3000? Hello world. Okay, the hyphen has not picked up the, okay, what's the name? What's the name that you're having? Okay, let's pass app name, make it Forinda. Okay. Okay, so okay, looks like something failed. Invalid app name. So did I make it a number really? Okay, okay, app name should be string. So that should be the default one. If we don't pass any, if I refresh, now execute, you should see hello world Forinda. Okay, so world was the name that we are passing as a parameter. Forinda is now the injected value, and you can see it's able to load those environment variables from your env, and you're able to retrieve them directly using the at value. If you're not using the at value, you can also utilize the you can auto wire. You can auto wire. Sorry. This now will be conf. So we can use the config service. Okay. So you can have the config service. Then here you can just use the conf dot. So you can get. Okay. With that, you can see you're still able to access the actual keys that we were having on the other side, right? Let me just change production icon here. All right. Okay, that looks good. So let's see if, okay, let's change this now from app to database URL so that we confirm whether it's working the way we expect. Execute. Now you can see you're able to retrieve that value there. Okay, so this is how you can use to get environment variables from your application. So I recommend you use this approach. They are typed, type safe, to make sure that if you misspell something, you catch it ahead of time. Okay, so what if now you're not in the context where you can inject? So let's say you want to extract something out of the environment variables directly to maybe your process. Okay, so let's say you are here in the root file, then you need to log something. Okay, so const let's say const port, we're assuming is 3000. Okay, by default it should get to 3000, but we can use the get env. Okay, so this get env is coming from KickJS also. So this kick env, it's also type safe, just the same way the others were type safe. So you can use this to extract environment variables directly. So let's call it log level. We'll set this to debug, so I'll just log here. We can also import here logger. So I'll just say const logger. So I just have logger dot for. Okay, so then I'll just logger. So I just write that debug. So then say, let me save that. Okay, that will only work if I restart these. Let's try and execute. Do we have something? Okay. Yeah. So you can see we have set this to debug, and you can see this is the logger set here. So you can see starting up level in debug. Okay. So did we set debug in our env? Let's say now it's info. Okay. Log level. Let's say info. So reload that. Dun, I think I'll need to restart this because it's just above everything else, but I'll need to make a request here so that it boots everything up, and you can see it's able to resolve the info here for you. So as you have seen, there are several approaches here. If you're outside somewhere, you can do dependency injection, like at the root here you use the get env. They should automatically also infer the type automatically for you. If you are somewhere where you are using you can use dependency injection, use the config service, you just inject it, should be able to resolve the variables for you automatically with TypeScript inference, right? So that is that with configurations. The next thing now is validation of requests, right? So I think let's go back to our configuration and revert everything to the way they were initially. Then you'll see what changed. Okay. So what's changed here? What's changed is now we are not tying everything to Zod. Okay, it's loosely tied to Zod. We can use 3 schema generators, that is either YAP, Valibot, or Zod. But if you're using Zod, now you'll need to install the Forinda KickJS schema, then import from Zod. Okay, import from Zod the from Zod function, then you have your Zod there. Alongside that, now the env schema will extract, you pass your Zod schema into the from Zod, should give you the schema itself, which should return a KickJS schema. Alright, so the KickJS schema, we will export the env, where now we'll pass the load env from schema, then we pass the schema, which is from this, okay, the one which has been returned here. But the load from env schema is now coming from KickJS config. So this is just to make sure that everything is backward compatible. You can use the old approach or this new approach for these kind of things. Okay, so where is it? So you import this from KickJS config. You get the from Zod from KickJS schema / Zod. I hope that makes sense. Okay, it's from Zod, okay, import from Zod, KickJS schema Zod, that is. Okay, definitely that will, if you need to debug your application, you come to KickJS here, you can inspect the schema generated. So if you're using the KickJS version, should be able to infer the output automatically from the env schema there. So if you come to these, you can see we are already having issues because these ones do not exist in the configuration. Okay, if now I add it back, now you can see that is gone. Okay, so that's how simple it is to use the KickJS configuration schema. The next thing here is after configuration, now let's go to API request and request validation. Okay, but because that is now where our business logic lies. So you can see the config service here. So majorly services hold our business logic. Let me just now remove this section so that we remain with whatever is necessary for this application. So let's say we come back to our controller. Now we are doing request validation for this application. Let's try and do something here. So we'll have our, let's call it details.ts. So assuming we want to create something, let's say I have like to-dos. Okay, so this service will have like to-dos. So this, we won't need this for now. So let's say we have private to-dos to-dos, which will be, let's have those to-dos, then get, instead of that I'll rename reference, so get to-dos, so this will be title, okay, okay, so get to-dos should be able to, no, so this should be create to-do, so yep, so get to-do by title, so get to-do will be, let's say ID, this will be ID, so just filter, just need to find, use the find method to get something, let's say we need delete, okay, so this should be type to do, have status, pending or completed, then this should be to do, can't type, okay, status pending, let's say this is completed, right, so status will be pending, so this should be a new to do, okay, then we push that new to do, this should be to do status, where to do dot status, so we wrap that, okay, right, so back to our controller, as you can see, one apparent thing here is so the index, we can remove the health for now, it is not necessary, so they should get to do's, so at post, can say at post, just the root, then create, at the moment you'll see the create does not exist, so KickJS will invalidate and create this in just a bit, so don't worry about it if you see the errors, but from the CTX you can be able to get the body. So if this persists, you can be able to see from the, you can inspect your routes here, you have your hello controller, we have the health, looks like it hasn't been invalidated, so you can flash it by just saying pnpm type gen. If things are not working, so it will flash it out. When you come to your controller, you should now be able to have the create here. At the moment you will realize the body is just any. The type for body is any, so you can't get the title. And also so these will be, let's call it to-dos. Can't spell it right today. Refresh this. Now it's under to-dos. API v1 hello. Call this to-dos. Refresh. Should have to-dos here. Now if I go to the body, you'll see I have nothing to try out here, so it's just telling me internal server error. So how do I know what's going on here? How do I know what's going on here? If I inspect the console, I'm seeing cannot destructure property title of ctx.body as it is undefined. Okay, so we can't really see this, so let me just show you how now to go about that. You come to your controller here, in the details, export const create to do z dot, so import z from zod dot object, just have the title, then create to do. In your hello controller, I'll come to the get where the post. Okay, so we'll have validation. So we'll say here body, then we pass our create to do. Okay, all right. So once we have that in place, should be able to run type gen. I don't know why it's taking time today to generate these types, but you can see at the moment now we have the body having the, it's already inferring, you can see it's inferring the to do that we are having. So you can see the title here is string. So if now we go back to the Swagger docs, you can see now we have the title reflecting here. Now we can test it out by just posting this. You can see we're getting some error, expected invalid input, expected object received and undefined. I'm not sure whether this is this might be something to do with the middlewares. Let me see. Express. So let me just add here express.json. So import express from express, then pass that express.json middleware and try again. Yes. So the issue was express JSON not passed as a middleware. So that's a caveat. Maybe you may need to take consideration of that. And you can see now we have our to-do created. If we try now to get to-dos, execute, should be able to see we have that to-do appended here. All right, we have that to-do appended here. If now I create another one, let's say another to-do, execute, another to do, status pending, rerun this. I should be able to get the another to do. So that is how you can do validation of your inputs, and KickJS will make sure that you get type safety end to end. Let's say for this get, I don't think if we need these, so we don't need that. So let's say, okay, you can see it's inferring the filter here, which is not necessary. If we pass it, well and good. If we don't pass it, also well and good. So you can see if you want to validate the post, the body, you just pass the body, then you pass your schema. This should support both Valibot, Zod, or YAP schemas by default, right? So that is it. What you should not try to do is, let's say you say ctx dot body dot x is equals to 30, right? So this, okay, it will warn you this does not exist. Let me try, let me try if type check will work. Pnpm type check. So this is now to just try to check if we can assign something to reassign, and you can see TypeScript is already inferring we have an issue there. So that is for request validation. If you don't want this long, maybe the type safety is not that important for you, you can just, let me say for this one, it's not that important. So you can just strip off this bit. You don't lose anything because you're just using the CTX. So already it has these methods here. So that is it. If you want to now validate parameters, params, you can also pass that. Query, you can also pass that. So that's how we go about it. So that is it for request, body and query validation. They work the same way, and whatever you pass there, it should be able to infer it for you so that your body is type safe. So let's say I add maybe description. I add description maybe, and status, tags, status. Okay, so I add all those, come to our controller. Now if I check on the body, you can see it's automatically inferring all these values here. All right, so it's able to automatically, so this, as long as it's inferred, you'll get type safety end to end. All right, where now you can import, you can export type, create to do DTO, then you have your service expecting that. Let me say so this one, let's say this is payload. So for now we're just doing pick, create to do that. So that should just extract the title from it. Then we have the payload. This should be an object. Where was this title coming from? Payload. dot title. So now if you come to our controller, you'll see it won't pick, it will start having issues. Now we just pass the payload. Just pass our payload there. Oh, not payload, the ctx dot body. So that is it. If now you have done your validations and you see you have all this figured out, we also have some cases where you need to do extra validation and you might need to throw inline errors. You can try using the, let me just use the try catch here. So this should be catch error. So you can throw errors here. We throw new okay, let's just throw an error. So this is simulated error. So let's try create, execute. See, we have internal server error. If you try and see, you're seeing our error handler unrecognizable schema. So these, okay, these are errors based on these ones here. So let me just remove them. So they are unrecognized, so that we have something clean. Execute, still have an error. Failed to create to-dos, and you can see this is failed to create to-do simulated error for demonstration purposes. So that is the bit we are demonstrating errors, okay? So you might need to return an error. So there's this method you might need to use, dot problem dot, so we have some validation errors here, like let's say internal. Then now you pass in your the problem input, okay? So it will need so just need maybe say title, maybe fail to create to do. Then let's just have that, remove this title from process. Okay, so save that. So you can use this ctx.problem.internal. So if you are forbidden, you can use the forbidden, but we'll use the internal. So this is internal server error. Execute. This now should give you a structured error, which is maybe status code 500, title that, then you have the type. Let's say I make this a message. Then now if I execute this again, now we have the message here. We have the title. I can also have the detail. Can just switch things up here. Okay. So this is more of the standard way for doing error handling according to RFC 9457. All right. So this doesn't stop you from using the. We still have the internal ctx dot forbidden okay, not found. So there are these deprecated methods like not found. So you can see we are shown here that prefer to use ctx.problem.not_found, which emits this one. Okay, so currently they are staying here for backward compatibility purposes, but you can use the .problem.not_found. Okay, so if I run this again, you'll see I get a 404. Our status code is 404. So this is the recommended way for doing errors in KickJS going forward. So you use the ctx.problem. So how you can this is now in the controller section, or if you're using some other context that we are having, as long as you have the context itself. But I think it will open up as we go along the way. So that is it for errors, but also we have ctx. We can use the ctx.json. Let me say JSON. We can always pass HTTP status. Then we have this list of status codes. So let's have internal server error. So these are just error enums that you can use. So also we have HTTP exception. So throw new HTTP exception, which takes in the status, which is the number, let's say 500. Then now here at this point we just throw. Okay, so we throw the error. So we throw the error again. Then now if I come and execute, you can see we have that error, but status code is 500. Okay, so sometimes you might need to process these error messages. That is the default way by which KickJS handles it, but you might need to process these errors by yourself. So you can come to the index here. So we have a few things you can add here. So not found. So we have the on not found and on. Okay, so we have the on not found, where you have so let's say you want to tell someone that the endpoint they're looking for is not found. Oh god. So here you'll just say detail is that, then path will be request.path. Then let's say if now I try to access something which does not exist, then you can see that is now whatever is being loaded. By default, if you don't have passed this on not found, then KickJS will default to the internal one, which is just message not found. So you can override that. Also for error handling, on error, so we have the on error. So so if you have an error, we just log this, unhandled error. So this is if you want to override how errors are handled, then you can use that. For now, let's try and see. Where is it? So execute this. We should get some error. Then you can see we have this error, unhandled error, that. So these are just some ways by which you can override the default functionalities of KickJS. So you can have your own error and the on not found just to make sure that you have a fall through. But also I told you we also have the middlewares you can pass here, which are just middlewares for Express. So this is where you can mount them. So the next thing here now is to talk about something here known as adapters, okay? Because we have handled controllers, I think that is a bit straightforward now. We have handled the DTOs and how you can do request validation using them. We've handled services and injections. So if you need to plug in your database, you just plug it the way you so wish. So we really don't dictate how you do plug in your database services. The next bit here is let me just go back to the KickJS documentation and see what we are having. So we've talked about decorators mostly. So there are decorators I've talked about, that is the controller, we've done controller. The service, we have used that. Can also pass the scopes. Injectable component, this rarely will use them, but they're just, you can just use service for almost all of them, but syntactically or flavors for database repositories, you can just use the repository. They will still be injected in the container. We have done validation, that is through creating this, the schema, which is Zod schema. Then now you pass it as a param to the post, this post annotation. So the ctx.body is validated, and you have seen we are getting the validations correctly. So if for the body it validates request.body, for query it validates the request.query, and params validates the request.params. So post construct, this rarely you'll use, but at some point you may use them. For me, I haven't really found somewhere to use them, but this also exists. Controller, we've talked about. Middleware, okay, we haven't talked about middlewares, the internal middlewares. File upload we haven't talked about, so I won't talk about file uploads because in the current setup, maybe the things I'm using, file uploads is majorly handled from the front-end side. So but you can read for yourself on the file uploads section on how it handles the file uploads. We have the auto-wired and inject. You can use the auto-wired, which are resolved by type, and the inject also injects the token, but also auto-wired can also accept a token. Property positioning, okay, but you need to enable this emit decorator metadata, emit decorator metadata. At value, I've shown you how to extract values directly from the env using the at value. Also we have the at builder. So at builder is a very interesting version. Let me just demonstrate how it works. So it's a static builder, so let me just show you how that works. So let's try and compose let's compose it. So you have your builder, let's just call it to do DTO, okay? Let me just call it class to do DTO, okay? So to do will have title, it will have description, tags and maybe status. All right, so you decorate it with @builder from KickJS. Okay, you don't need to call it, you just decorate it with @builder. Then how do you use this now? Okay, so if you check here where we are creating our to do, okay, we can just eliminate that, then say const new to do will be to do dto dot builder. Where is it? Dot builder. Okay. So currently it's not type safe, but it should be working. Okay. Set the title dot, let's say, description, then are the tags, then finally, then here you can say dot status pending. All right, so this, it works, yes. So we push this new to do dto. Let's go back to our controller and remove these errors we were having. We just have them removed. So when you are creating, back to our execute this, you'll see we are having another to do description. This is a new to do. You can see we have KickJS, we have the tags, to do's, and status is pending. These are values which are from this builder, right? So let's say SSS, to make sure that everything is working correctly, execute, and see. Oh, all right, yeah. So you can see SSS is appended here. So if now we try to execute and fetch, you'll see we have these to-dos with the SSS. So that tells you the builder is working. So how to make it type safe is now how do we do that? So you can extract this, the declare static read only builder. So we come back to that class. So oh god, so declare static read only builder, which we import builder of from KickJS. Then this should be to do dto, right? So then this should do the mix, all right? But we don't have the ID, all right? So where is the builder of? So this should be type, but you can see we are lacking the ID, that's why it's complaining. ID number, then in here whatever we return, so push, so what is so to do is not a parameter, to do type, status are incompatible. How are they incompatible? So ID title, okay, ID title, description, tags not there. Right, so remove that. remove the tags. What is undefined here? Oh, okay, I see. So status is not undefined. So we provide a default for that to make sure that it's not undefined. Okay, so that should fix the issue. So that is approach number one. You can use that to statically build your payloads after receiving some data from them. So you just use the your dto.builder, then now you build everything one by one. In here you can also do validation for them. That is approach number one. The next is to use the with builder here. So just import the with builder. Approach two. Where do you just, let's call this to do user base. Okay, all right. So then we remove that. Then const, we just say a const to do DTO. Then we call builder. No, with builder. With builder from KickJS. Then it should give you the same approach, and you can see nothing has broken here. We still get the same values, right? Then it should return to you the base DTO, right? That should work just the same way we were doing the other one. So you can choose whichever you wish. Also, instead of having this, you can just export this as a class. Then now it extends, oh god, extends this, then you just have it as an empty class. They should also still work. So this is the part where now you can use the at builder decorator to statically build your payloads. So I've shown you two approaches, using the static builder and using the at builder, the with builder pattern. So all of these are in the documentation with KickJS here. So for Swagger, you can see we have, let's say for instance, currently if I refresh this, you just remove, you can see at the moment we are just doing the tagging. Okay, so get back to our controller. That will take us back to the controller because that's where they're used majorly. So so let me have this as create to do DTO, create body. Also you can rename this name to create to do, so that your schema is renamed here in Swagger. So you just pass the name, it reflects the body, not the other ones. Just in the schema section, this will override the default create body that you're having. So the next bit is now talk about more of the OpenAPI things we are having here. Let's say I add this to our, is it post or get? So add this to our get, list all to-dos, then returns all to-dos to-dos, but we need to import this OpenAPI operations. Come back to here, refresh the get, then you can see the list all to-dos. This is now the summary, then returns to-do lists. Then now you see this is, it's giving you the details here. Okay, so let's say if now we needed to have parameters, let's say we have some query. Export const fetch to-dos, let's say with status. So I'll just need to extract that, come here to our to-dos in the get section. So query, no, it's params. Is it params? Okay, save that, refresh. I'm not sure if that has reflected. Is it query or okay, query? I'm not sure which is which. Yep. Okay. So you can see we are having I'm not sure why it's not showing the okay, all right, it's showing. So you can see we are having the fetch to do's, which is we are having the statuses, which is either pending or completed, and you can see in the status is able to give us here. We can fetch those which are pending, and you can see the ones which are pending. If now looks like it's not really doing the correct filtering, but if you wire that up, it should be able to do that for us. So that's how you can, just passing the schema itself should be able to pop these parameters for you automatically on Swagger. So operations now will give you this, it's just for description of your OpenAPI specification. So if you want to describe a response, let's say you have these ones, you can also add those ones alongside. I think that should make sense here in the create section. Just add those, the response. So create, I think create to do. If now I refresh this, come to the post, now you can see it's able to create response. This should give me the details of whatever we are having here, and it will infer the types, the examples based on the schema that I have passed there. That is for the API response. So you can do the API response with statuses to make sure that they reflect based on, so if you have this 400 validation error, if you have success, then you have all these. Okay, right? So let's see the next one. We have tags already, we have tagged. If now you need to make sure your endpoints are secured, we can provide this API bearer auth on top of, at the controller level. You can decorate the controller itself. So currently, if you check these endpoints, you'll notice they are open. Okay, you'll notice they are open here, so no locks. But if you refresh now, you'll see they are locked, and Reason why they are locked is because I have passed this API bearer token. So if I authorize test, authorize that, then now you can see, okay, I can try it out, then to use that token. Okay, all right, so that is, for more information on how to do more on this, you can just read through the documentation on this. So if you need something to be public, you can just say maybe this one, for this one here I might need it to be public. Okay, so refresh that, you see now only this one is locked. So that is it majorly for OpenAPI documentation. The decorators you need, you can just stack them on top of each other and it should do no harm. Majorly they are used in you use them in the controller context. So let's try and have this maybe at API exclude, then then now you can see you can exclude also some endpoints from OpenAPI specification. So you just use the at API exclude, you should be able to remove them. So with that, I think most of the things we have done with OpenAPI just okay. We'll just leave the tagged details on top here. API query strings, these are now a bit advanced, a bit. So these are, let me just show you how these now work. So in the get here, let me just put that. If you use that, it will change the face of this. So for instance, let's say now if you use this approach with the API query params, you pass the filterable, sortable, and the searchable. What that will do, it will expect a payload that looks like this. Okay, so this is the expected payload. So you have the field operator value. So this, for the sortable field string, you'll need the field and the sorting direction. If you are using the filter, you'll have this, just one filter, and you have the operator and the value. So that is if you need something of that kind. So if you need to search something, you'll pass the queue, then you pass the page size and the current page that you want to get data from. If you're using this, then there's something maybe we'll touch on later, but it's a bit advanced at the moment. Majorly this is how you would use it, but it's a bit advanced. So we have list of all the decorators listed here, but now switching gears a bit, from decorators now we are supposed to handle dependency injection, which we have handled, but I don't think if we have handled everything. But whatever we've handled, I think is just okay to work with the way it is. I've talked about the service, repository, component, but you can choose whichever you so wish. Okay. So the token, I think we tried some of this some time back. Property injection, these ones, okay. I think these are now some things you can go and learn from the documentation. But let me just go through some a bit here. So majorly you might find that you are using these interfaces. You inject the interfaces to your controller, then now because the repository you're having, it's a class which will extend the, let me just demonstrate that. Okay, so let's say for instance so create to do DTO. Okay, so let's say I have to do dot repo dot ts. Okay, then export interface to do repo, let's call it I to do repository, which will be to create to do create to do DTO, omit ID, find all, filter, which will be pick from create to do DTO. What we'll pick here is the status, then should return to ours, maybe create to do DTO, create to do DTO. Okay, so we have this we might have this kind of repository. All right, so what happens is we have our this service here. All right, so this service will need now an actual repo. Let's just call it repo.ts. So export class to do repo implement. So let me just right, so import create to do. All right, okay, we import these two. Okay, so what happens here is we have the to do, which let's decorate this with at repository so that it's discoverable, right? So we decorate this with at repository. We implement the to do repository interface. So what we'll do there, we'll take this I to do repository, come to the service, then instead of having these ones, we'll say at inject. Okay, so before we inject, we come to the repo itself. What we'll do, export const maybe to do repo token. So this token, we should use the approach for create token. So we just write create token, right, from KickJS. Yeah, what's this? This should be, let's say, app to do repository, right? So they should just be single. Okay, let me have that on top there. Where were we? In the repo. All right, in the repo here. Oh god, how do you format in Windows? Okay, so you create this token, then we'll just scope it to it's an app, then you say to do repository. What you do with this now, instead of injecting the service directly in the service itself, service is injected to the controller, so we use the @inject, this one. Then what we'll have here now is I to do repository, right? So this should still work. So call this repo. So then this will be oh, okay. Think I'll need to extract these now to import the with builder. All right. After importing the with builder, now I'll get back to the service. In the service, what do we need? We need to do so in here. What I'll do is to extract this where we are creating the to do, bring it over to the repo itself. Where are we creating? So we create here, all right? Just using the to do. All right, we're just doing some bit of refactor here. So we have moved things to the repository, or we can just create it from the service side, then we just bring whatever has been validated. So that's the cleanest approach. That's the cleanest approach, I think. Extract these to here. All right. So then, so this dot repo dot create that to do. So the repo will create that to do. So this dot repo, so this dot repo, let's just have the repo do the filter for us. All right, so it already does the filters. Then find return. Right, so we are using the repo to find everything. Then here get it by ID. So in the repo, I don't think if we had it. So find by ID should do that. Come back to the repo. We need to implement that interface. Okay. So this ID is a number here. What is it? ID. Right. Did we omit anything here? To-dos. Looks like we don't have ID. Okay. So here, so you don't need to omit anything here. So this should be to do. just return the to-do that we have created. Then what next here? We need to find all the to-dos where the ID. So this dot to-dos looks like the to-dos we are having here. Okay, I see. Okay, I see. So our repo, we need to have, our repo needs to have under, let's say ID number. All right. So ID number. All right. Let me just say type of. So this we'll have it at the base, so that does the base have all right. Right, so that is fixed. So just add here the ID so that when we find by ID, it knows the ID we are looking for. So come to the service. This dot repo dot find by ID. That should be straightforward. So remove this title from here. Delete anything that is unused. All right. So with that, we should have our API still working. I'm not sure if it's still running. Yes, it's running. Test it now if it's still working. Try again. We are getting internal server error. So what's the error? We can't really see the error. So let me remove the index. Okay. Let's just log that error and see. Okay, the same issue we had some time back here. So it's saying no. Okay, this is a bit straightforward now. So the error we're getting is saying the cause for this is app to do repository was requested from DI container, but no bindings is registered. So usually means we have used any of these, but okay, we haven't mounted. Okay, it's not mounted. So what's apparent here is we need to bind the actual implementation. And how do we do that? We'll come to, where is it? The KickJS module. Then we'll need to call the register, which will contain the container. So if you call this register, it has the container parameter. Okay, so you can, at this point you can see register container is optional, only implement it when you need to bind a token to a concrete implementation, e.g. register container, so a repository then. Okay, so okay, so let's bind this. Okay, pum, 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 pum. All right, so let's bind. So c.register, what do we need to register? What's the token? It's to do repo token. What do we bind it to? So we'll just say here c.resolve. So this should be hello service, right? So okay, we can just register the hello service. Oh no, hello to do repo. So this will be c.resolve oh god, why is it not working? Let me see why. So okay. Oh, it's register factory, not register. It's so it's register factory, not register. So this means we are registering this to do repo token to this one, of which the add service already puts it in the container. So we just need to resolve it. Let's see if that works. Let's try again. Oh god, I hope this works. Execute. Oh, okay, it worked. So we are getting empty. So let's try creating one and see, confirm end to end if everything is working correctly. Execute. We have that. Execute that again, and you can see we are having, yeah, it's working end to end. So you have seen some approaches we are using here. So if you're someone who likes doing you have your interface, you bind your interface to your service, you might have several of them. Then you bind your interface, you create a token for that interface, then you use that interface in your service. Use that interface, you create that interface with its token, then you inject that in your service, and you implement that interface so that the interface matches whatever you inject in that. The class, the repository class in should match the one that you injected in the service. So in the service, it will call the repo, which will be resolved at runtime. Then that repo will need to inject that actual implementation in our module at the module layer here. inside the service, but now instead of using the register, we now use register factory. So this factory will make sure that when it's trying to resolve, it calls this to resolve the class that we have provided here. To just attempt to extract this class from the dependency container. So that's one of the caveats maybe you might need to check on if you're working with KickJS. I think that's majorly it. I think we've seen the register factory. You can use this for even registering your database interfaces and so on and so forth. If you have some things you need to register that are not classes, we'll see how to go about that. So yeah, that's it. I think I'd also talked about the configuration. So one thing you need to take note of is majorly the request lifecycle of KickJS. Majorly we are using async local storage for handling requests, so that we abstract a lot of these things for the clients. So another thing here now to move to next is I think okay, these ones you can look up them later. I don't think if much going on here. We have testing, but let's go to modules first. So modules. So most of the features in KickJS are just, if you need to extend KickJS, you'll see we're using modules. So modules are just used to bootstrap everything, just bundle your controller, your services. A business logic mostly lies in the module section. I think we've handled a bit of things on the modules where we have the build and we have seen how to use the register. You get your container, the dependency container, then you can register containers. You can also use the resolve here, and you have your routes where you can return your path and the controller itself. You have the name, the build, which can take the config, and the context. That is now the context of the application, not the request context, that is. So it is more of the build context. We talked about these ones, the routes, return one route set or an array of route sets. The framework derives an express router from the controller via build routes. So this is more of an internal thing. The legacy way of building this was more of using this class implements app module, which was a high level interface. We were using this kind of matchers, but these are effect imports. If some things are not working, you might need to use this import.meta.glob to match patterns to automatically resolve files that you might not have imported. Okay. One thing I haven't talked about in these modules. So if you have these routes, let's say I return an array and maybe I need to work on version 2 of this application. It supports versioning by just, we can have to-dos, then for this I'll mount it in version, let's say 2. Okay, so if I set that, refresh, you'll see I have, you'll see I have now these two, the version 1 and version 2. So that's how simple it is to do versioning on these controllers. So you can version at the module level. All right. Don't worry about that, because maybe for most cases it's just good that I mention it so that if you need, you might use it. So I think we've talked on the modules and you've seen how we are using them. Module routes, we take in the path, the controller, router, then the version number, okay, which overrides the application defaults. So okay, if you have to provide multiple version sets, this is how you can do it. You have here to do controller, version 2 controller, to do controller, and maybe to do admin controller. You pass your to-dos, say version 2, okay, you mount that version 2, then you mount the admins under admin to-dos, then you pass the admin controller. This should give you the path, this variant of paths. Alright, it's good just you get that. So factory binding, I think to switch from in-memory to a database, change the factory. So majorly, reason why I like this approach is because if I inject the token at runtime, I might, maybe if I'm testing, I need to pass an in-memory repository rather than the actual implementation. So also the module can have its configurations if you want to. So you can pass your configuration, let's say scope, public, what and what not. So just define your module, pass the config, you can pass the defaults, then you can use those defaults to probably map to whatever you want, okay? So maybe you might want to mount one maybe on this scope and mount another one on something else. It doesn't really matter so much. So composing modules, this is how we used to do it. You can use the plain array where you have your app module entry, then you have this. But we also have the fluent way where we use the define modules, where you mount modules by just calling the dot mount, then you call the module itself, and you extend these. Right. So that is it. When now you have everything put in place, you import all the modules, pass the modules to your bootstrap, the way we have done here. Import modules for modules, pass the modules here. Okay, conditional registrations. Do we have this? Okay, so this is now more of setup. There are more interfaces for the setup. You can, let me just check. So when the app is setting up, you can also did I? So where this setup section is run, so imperative module registration callback receives module registry. You can mount a module onto register modules conditionally based on env flags or runtime configuration. Maybe a tenant list run after every plugin setup hook after the static modules array is collected. So you can get this registry, then you can use the registry dot mount. So you can also use this to mount a module. So that is also somewhere you can use to mount your modules. All right. So that is it majorly for modules. There's not much going on there. Right. So config, let me see. There's something here. We have in the build also, we have the setup. I believe so. So what does setup do? Registry R. I'm not sure if this is, I don't think if this is there. I'm not so sure. I'm not so sure if this is there. But you can use the base, the root level setup if you wish. I'll take a look into it if it's a bug or not. So the next bit is controllers and routes. I think these ones we've talked about. Yeah, we've talked about these ones already. So one thing that I'll mention here, we have this route decorators, delete, get, purge, put, and so on. Then we have the request context, which now is the CTX that is being injected to your controllers. So we have the body, params, query, headers, request ID, which is automatically set up for you. We have the file and files when now you're using the add file upload. Query string parsing, we have the QS. They should be able to do the automatic parsing for you. Metadata key ctx.set, you can use this to set values. Ctx.get, you can use that to get values from the context. Response helpers, you have the JSON who pass the status, created, no content to a form, majorly for put patch, not found, bad request HTML to return HTML content. Download, you pass the buffer and the file name and the file type. Render to render template. Pagination, this is more using the QS. So if you choose to use this, then you need to pass this callback to it so that it's able to pass that down to the callback. This is the shape of the response if you're using that. Template rendering, this I haven't really tested because I haven't found somewhere to use it. We also have the ctx.sse for server-sent events. All right. So you can dig more into these in the documentation. So we have also the middlewares. I think I'll talk about middlewares at the point where we're talking about the middlewares themselves. Okay, dependency injection, we've talked about that. Constructor, all right. So something also I didn't mention, let's say KickJS comes in with its logger, inbuilt logger. So let me just delete all the unused imports. So you can import logger, all right? So you can import this logger. Then you can inject at inject logger. So when you try to get things, logger, so this is the logger.debug message, then extra arguments. So let's try and refresh our get. execute, we have empty, then you can see received query. Yep, the logger is working. So you can also inject the loggers if you don't want to use the console logger. You can just inject the logger from KickJS and use it if you want, that is. So that is just something I thought I should mention. The next is more of type generation. So KickJS has type generation, and this is what now powers the TypeScript or the type inferences. We have a folder known as KickJS types at the root of the folder, where we are able to have Zod schemas, but now they're not more of Zod schemas. This pattern is modeled on React routers .react router types. Also, we have the Next, which is also using the .next. We also have Next.js, which is using the .next. So this is more borrowed from the established frameworks that are doing the backend and front-end application bundling together. So that was something we could use for, we can leverage on that for the front end, for the backend, that is. Generally what is generated, we ignore everything in this folder except the ignore itself. All right, so we ignore everything in here to make sure that this is not git tracked automatically for you. So, but also in the git ignore, we are also ignoring it just for safety purposes. So we'll have everything exported from this, then registry, services, modules, routes, and the env itself. So 4 things become type safe, that is the container resolve. You can resolve using these tokens, returns user service instead of any, ctx.params, ctx.body, ctx.query. These are typed from passing Zod schemas. QS also narrows down these to these fields at a value, which is more of the environment variables. Quick start, I think we have done this. We talked about our body validation and we tried it out. We have the kick routes, ctxt. It's just a thin alias for the request context, but it's very lean, so you don't need to pass so many things to it. So command, you just run typegen. Does this work? I'm not sure if this works. It's been long since I used, so try that. If that is working, I don't know, but it's worth trying. It's worth trying. It should be p and pm. All right, so this is watching for changes. If I refresh, it should tell you it's watching for changes automatically. If you're tired of running typegen every time, you can have two terminals. Maybe one is just watching for typegen, another is watching for. Let's try if it's working really. So let's try create a patch format with, then let's just have this as patch. So this will be update, then this will be a patch, import patch, save, and you can see automatically it reflects. So this can help you to maybe fast track the type generation very fast, and you can see it reflected immediately. So you can use that, and anytime you find any issues, type is not inferred, you can always check here if the types are generated correctly, you can always come here and inspect. Like the update here is now the body is inferring whatever we have in the schema we are defined. You have your modules, plugins. This will appear once we start plugging in adapters or our plugins. Registry now, here is where everything which is the container registry will be here. So you have no need to worry about how this looks, because it automatically resolves it for you and have the paths fully put in place for you. Services, this now the service tokens that you can be able to use. So let's say how can I, okay, let me see in the module. So in the results section, let me see, we have to do repository, right? So I can resolve the to do repository, which will be that. All right, shouldn't have an issue. Let's see if that still works. Internal server error, so that failed. So it's good if just pass the class, don't use the string methods or the strings to access those dependencies which are injected, just to avoid having issues. Let's go through this. Okay, don't think if we need to talk so much about this. Okay. So this KickJS is more opinionated, so you can just use the query, normal query for you. It doesn't matter, you can ignore it altogether. So I think we've talked more on these sections a lot. So if we come and inspect the TS config, you'll realize we are including also the generated types in the KickJS, so that TypeScript is aware of the types that are generated, so you don't get the hassle to include them by yourself. All right. So that's that. I think this is done majorly. So let's talk about middlewares. Okay. So we have several middlewares. So there's this. KickJS provides middleware at 3 levels: the global applied to all requests, class level applied to all routes under that class, and method level, which is applied to that single route itself. So the middleware type will take the context and the next. All right. So this is how it looks like. So auth middleware, let's say you are defining auth middleware, you import your middleware handler and request context. Then you can use this to, the first parameter is the CTX, and then and the second is the next. So what you do is you can do your normal express stuff in here using the ctx.headers, or you can use the ctx.request.headers, still will work. Then you can use the ctx. So the ctx is now the context that the HTTP context that you're having, you can be able to use that. Then after you're done, you just you pass your next. All right, so you can set the user. Then after setting the user, you can now use the ctx.user get user just in the next handler that you're having. With that, you have to use the @middleware. This does not use the normal express middleware approach, so that's why you need to use this @middleware, and you can pass them as arrays, or it just takes the args, general args, for passing the middlewares. So you just pass your auth middleware, then you just ctx.getUser, should have to get user, then you return the user. Method level just does the same, right? So so Bootstrap has its middleware, which is request response, next function, @middleware, which takes the context and next with the KickJS request context. We also have the adapter, which has its middleware, which is request response and next, which is having the it's like the middleware, the Bootstrap level middleware. All right, so you can see we can pass these middlewares, helmet, cause, Morgan, pass the middlewares at the Bootstrap level. If you omit the middleware option, sensible defaults are applied, like express.json and request ID. Global middleware entries can be path scoped, so you can just supply them on a specific path. That is right. So also we have some context known as adapters, but we haven't really talked about adapters, so it's way ahead of us. But it also has the adapter middleware, which now has you have the handler and you have the face. So you have faces which you can use to sort your middlewares on where they should be called. So maybe before routes, maybe after routes, maybe after mount. So we'll be able to, so let's say if before mount, adapter hooks early, right, like health or docs. After global, so this is the order: before mount, before global, then we run the global ones, after global, then we run the DI bootstrap, before routes, then we have the routes, then after routes, then you have the error handlers. This is how adapter middleware looks like. We have the handler, face, and path. If path is omitted, defaults to after global. If face, not path. Custom error handlers, I think we talk about the on not found and the on error. Writing some reusable middlewares, you can just say having a role, create a factory which returns another function which is now taking the request context and the next, then check if user is there or not. If the user is there, then you give them a pass through, right? Won't talk about circuit breaker. Trace context. No. Right, so let's talk about a very important concept in KickJS known as request context decorators. Okay, so context decorators are typed, ordered, declarative in a declarative way. So set key value before controller handler returns. They replace handwritten middleware whose only job is to compute X and stash it in the request. So one thing, it good fits span well beyond multi-tenancy. Anything you repeatedly compute from the incoming request is a candidate. So request tracing, metadata, local, feature flags, experimental buckets, rate limit, geo, and maybe device info, workspace organization, warmed users profile, and permission set from the cache, whatever per request value your handler keeps rederiving. So let's say you have to resolve a local, then load a feature flag, which depends on the local. How this works? Compared to writing the ctx.this, custom middlewares for the same job, you get type safety for ctx.get, then returns the type you declared. So we need to augment the request context, the context, not any. So ordering enforced at startup. So when you set up the depends on property, it should be able to order them in order so that they are resolved in order. It has also dependency injection integration, so you can easily pull up something from the dependency container. So reusable across registration sites. The same decorator works at method, at class, at module, an adapter, or globally in the bootstrap. When to use the middleware? Middleware's only outputs the value other code read of context. So you want type safety on the value. The value depends on another value computed by an earlier middleware. Okay. Stick to middleware or express middleware when your handler short circuits the response with the status code 403.end. It manipulates the response stream, maybe compression or body passing. It returns before a route matching calls or this related stuff. Okay, so more on this you can read on later. So I just want to go to how you get started. So quick start to get started on how to use this. I think we'll need to do some cleanup here. I know I haven't talked about code generation here at all, but I'll need to just do some cleanup. I'll need to do some cleanup here. So what I'll do, KickJS provides some very useful commands. So you can remove a module. Let's say I want to remove this hello module. So I can just say pnpm kick module rm. So I want to remove a module, say rm module hello. Okay. So hello is not found, so no pluralize. I'm not sure if that will work. Okay, so this tells it I need to remove module hello. So by default it auto pluralizes. So if you pass no pluralize, should match the exact way you said it. So yes, I want to delete that. So hello module is removed. You can see our module is clean. So hello is gone and our module is empty, right? So I need to generate one thing here. I'm using minimal. Let me use the REST approach. So instead of rm, we can use kick g module say maybe cow. Okay, so I generate a module known as cow, right? Should see it auto pluralizes the cow, pluralize, sorry, so automatically registers that for you. Come to the cow, you'll see we have your DTO, everything set up, create cow, update cow already set up for you, cow constants. Now if we check, let's check what we have on this other end. Now you can see you have cows. If you now come to try out get cows, now you see we are having the paginated approach of things, right? So I'm going to use this cow. See, we have the cow module. Now it automatically does the registration for us. You can see we have register cow repository, then container resolve, test cow repository. We have the repo here, which is an interface. We have the service here, which is just doing the using the repo to abstract these calls. Then you have our controller, which has the API tags for each and every endpoint. We have the delete, put, post, and get. Okay. So with this, this can get us started. So how do we get started with? Let's talk about the middlewares. Okay. So we talked about the middlewares here. So I'll show you how to set up one. After that, we'll automatically do the part for context decorators so that you understand the use cases. I think we are done the middleware section at Bootstrap. So next thing here, we can use pnpm kick g middleware. Let's call it test middleware. Right? Or maybe just call it cow. Right? So what this will do, you'll see the middlewares will have the cow. Let me just delete this first. So let's just call it cow. Let's have a middleware known as cow. Then you'll have the middleware cow.middleware generated for us. If now you check it, you'll see it will give you these options, which guides you on how to use it. Okay. So add configuration options, the factory below closes over. Okay, so you can have your cow, then you pass these params. So usage in the bootstrap, the middleware, you just call cow. In an adapter where you have the middlewares, you can call the handler, call it, then pass the face. So this is majorly used in the context for let's say I have this cow. So what I need us to say here is can just log, so console, okay, console, so let me just call this cow middleware. Then they say I can just call this cow middleware directly in my index where I have the middleware. Where is the middleware? So have that. So we have cow middleware. If now we check our logs, so currently we are not seeing anything. Let's go request. You'll see we are having more. Okay, cow middleware says hi with these options. So if I pass some maybe name, maybe Ken, run, should see I'm able to get the details here in the console. So this tells you that this middleware is working. Okay, so another approach for using the middlewares is so you can generate a guard. Now the other one is called guard. Let's say guard called cow. So this will go into guards. So it also has some highlights on how to use them. So protects your route by checking conditions before the handler runs. So return early with an error response to block access. So let's say like maybe at middleware cows guard, okay, get protected that. So we have cow guard request context next, just the same way it was shown in the documentation. Then just check if we have this. So what I'll do is so we have cow guard. You can rename it the way you want, but it doesn't matter. So let's where's our controller? In our cows, in the get section, I can pass at middleware. Okay. Then I have my cows guard. Okay. So passing that cow guard there. If now execute, so it's telling me missing or invalid authorization header. All right, it's telling me missing or invalid authorization header. So let's say I need this to be authenticated. Currently they are open, so I need them authenticated. So I'll just say at API bearer auth, call that, refresh, then try to get, execute, I get this. Then now if I authenticate, say test, authorize, close, now execute, you see now it's open. All right, so that's how you can generally use that middleware. You've seen we can guard it using the, we can guard our Swagger using the API bearer auth. Then if you need to pass a guard, you can use this middleware at the, let me just, I can also use it at this level, so it wraps everything. So currently, if you see this, you'll see others are still open. If I refresh now, let me see. Oh, I didn't need to shift that. So now you can see all these are protected. If now I try to, let's say, try execute, you can see missing authorization header. But if I authenticate with test, close, execute, you see I get a valid response. So that is how you can use the middlewares and the guards, and you can also generate them from the CLI. If you like the manual way, well and good, but you can use the generator, CLI generator, to help you generate the guards or the middlewares. So back to the concept of context decorators, all right? So we are talking about, where is it? Quick start here. So let's say if now you are someone, you need to how do I put this? So let me call it, let me create a folder here known as contributors. So one, let me call it one.contributor.yes, 2.contributor.yes, then 3.contributor.yes, right? So let's start with one. Okay, so one, let's say how do you create a contributor? You just say const one one contributor. What we'll say is define context decorator, right? So we'll pass the specification, so we'll have the name, which will be one. Then we'll have, oh, it's the key, not name. Key is one. Then we'll have resolve. So we have resolve here. Okay. So resolve, we have the context, which is now the execution context. Dependencies, which are now how do you call them? The dependencies you expect from the DI container. So it should be able to resolve those automatically for you, and extra params if you need them. So you can see it's context decorator, and so this context decorator, majorly you can't use this to decorate HTTP methods. So let's say export const one HTTP, which will be define HTTP context decorator, which will be one HTTP. Okay, so this one HTTP maybe will depend on, let's first have them. So this one contributor, let's have in the resolve return one, but in the process log console.log resolving one contributor with params, then this will return one, then we have this one contributor. So we take this one contributor, we can go to the index, then we have this section called contributors. So contributors, we pass an array, then we pass that. Oh, we didn't really export it. Okay, export. Come back to index. Then now you call dot registration. All right. So once you have that in place, check our terminal. Nothing is broken. So go again. Try to where is it? Execute. Cow not found. So you can see it was mounted globally, and you can see one contributor resolve one contributor. Okay, so that confirms that it's working. It's like a middleware, one or the other, but you'll just see the difference in a bit. So we have that one. Then let's say now we need to, one thing we'll need to do here, we say ctx .d.ts. Okay, so we need to do some things here to make sure that it's type safe. So we'll need to extract this, put it here. So declare module. Right, so this is going to fail us. F2. This is going to mess us real time. Okay, let's define it where we have the so it's good we define it where this is defined.